Let's use the circuit construction kit to take a look at a parallel circuit. We have two resistors here in parallel. Visually they look like they're in parallel, but the question we have to ask is how do we know that they are electrically in parallel? We have the battery set up here with 10 volts. We have two 20 ohm resistors. And what we find is that the potential along this wire, this is an ideal wire, is the same at all points. So I'm going to bring the voltmeter in. Down here in the bottom we can see the potential. And we see that at all points on this wire, we're still looking at 10 volts, 10 volts, 10 volts on top of each of these branches. And then once we've gone across the resistor in each branch, we're now at a potential of 0 volts. Whenever two resistors have the exact same potential across them, no matter what, these are then in parallel. We can guarantee that the top of the resistors are the exact same potential because they're connected by wire. We can guarantee that the bottom ends of the resistors are exactly at the same potential, 0 volts, because they're connected by wire. So these two resistors are electrically in parallel. The potential across each of these resistors, so we gain 10 volts in potential here. And then what we find is that across each branch, we lose 10 volts. So there's 10 volts of potential across this branch, and there's 10 volts of potential across this branch. We lose 10 volts of potential going down either the left-hand branch or the right-hand branch. The voltage for two resistors that are in parallel is the same. Now, let's take a look at the current. I have a series of ammeters in place here. For a second, I'm going to show the electrons. And we see that current is flowing down each branch, but there's a little less current down each branch than the whole. In fact, there's exactly half in this situation because the resistance of each of these branches is the same. When the current comes in, I'm going to turn off the electrons now, and we're going to trace with the cursor. The conventional current flows from the positive terminal of the battery. It flows along this top wire, and then when it gets to a point where the wire splits, some of the current goes one way and some of the current goes the other way. How much current goes each way depends on the resistance of each of the branches. But what does not depend on that is the fact that whatever current comes into this junction must go out either through one side or the other. So the sum of the currents leaving the junction is equal to the total current coming into the junction. This is sometimes called the junction rule. Now when we get to the bottom end, we have a ½ amp that flowed through the left-hand branch. We have a ½ amp that flowed through the right-hand branch. They recombine, and at that point we once again have a total of 1 amp flowing back into the battery. So we have 1 amp flowing out of the battery. It splits, not always evenly, but in this case because we have two equal resistors, it splits evenly. And then it recombines at the end of the parallel circuit. So the voltage for each branch is the same in parallel. The current is split and then recombines. Now, the equivalent resistance of this circuit, it turns out, because these are two identical resistors, equals 1/2 of the resistance of either of the two resistors. More formally, as you'll see in the text, 1 over the equivalent resistance is equal to 1 over the resistance of the first resistor plus 1 over the resistance of the second resistor. More casually, one realizes that as you add branches, you increase the total amount of current that the circuit can handle for a given voltage, and so you will increase the total resistance, the total current flowing out of the battery, and thereby you can speak of this as having a lower equivalent resistance. I am going to now change the resistance value of the left-hand resistor to 10 ohms. This will make it easier for current to flow. So now when I start this up, we'll make it easier for current to flow down the left-hand branch. 10 volts across 10 ohms gives me 1 amp of current down the left-hand branch. And this increased the total amount of current leaving the battery. We now have 1.5 amps leaving the battery. It splits. 1 amp of current goes down the left-hand branch because there is a lower resistance, in this case 10 ohms, and there is still a half amp flowing down the right-hand branch. When the two wires come back together, we find that we have 1.5 amps again flowing back into the battery. So in this case, the current leaving the battery is going to split and go down the two different branches, but no matter how it splits, the amount of current flowing into the junction has to equal the sum of the currents flowing out of the junction. And then down here, when those two branches recombine, we get the full current again. And the voltage across each of the branches is the same.